NetSim GenAI connects an AI coding agent with NetSim in a continuous feedback loop. The agent starts by planning the requested change. It updates configuration.netsim to modify scenario parameters. When protocol behavior must change, it edits the source code in NetSim. NetSim then runs the experiment with NetSim core.exe. After the run, NetSim writes metrics.xml, CSV files, and logs. The AI agent reviews those outputs and checks whether the target has been reached. If more refinement is needed, the agent loops back, makes the next configuration or source code change, runs NetSim again, and repeats until the goal is met. NetSim works well with AI agents because each part of the workflow has a clear file or command. First, a scenario begins with configuration.netsim. The agent can inspect parameters, understand the topology, and suggest focus changes. Next, source code additions keep protocol logic under SRC simulation, where an agent can inspect or modify one module at a time. Simulations can then run from the command line with netsim core.exe. The command gives the experiment path and license server, so the run can be repeated. After the run, metrics.xml and CSV logs provide results in files the agent can parse. Together, these pieces form a repeatable loop from configuration to source code refinement to execution to results. With this setup, an agent can read publications, standards, and design documents, then use that context to edit configuration.netsim and C code, run simulations, analyze metrics.xml and CSV logs, debug errors, and prepare reports. Now let's see this workflow in NetSim with an AI coding agent session. We created a one-site 5G scenario in NetSim with 3 sector GNBs and saved it as our base configuration. We then opened the saved scenarios file location from the NetSim workspace. The project folder contains the NetSim configuration and all the required supporting files. Next, we open the command prompt directly from the workspace path and launch Claude Code. Once Claude Code opened, we instructed it to create a 7-site 5G hexagonal scenario based on the existing one-site NetSim scenario. Each site should have 3 sector antennas, so the final topology must contain 21 sector antennas in total. Place 15 UEs per site, giving a total of 105 UEs, and distribute them clearly around their serving sectors. Once the prompt is provided, Claude starts inspecting the existing one-site configuration and its supporting files to understand their structure. It then creates the necessary files for the 7-site configuration, thoroughly validates the output, and resolves any identified issues. Next, we locate the 7-site scenario created by Claude in the workspace and load it into NetSim. Here we can see the completed 7-site scenario created by Claude in the NetSim workspace, with its site layout and distributed UEs visible. We now select the generated scenario and open it directly in NetSim. The scenario opens successfully, displaying all 7 sites with their corresponding GNBs and associated UEs. To summarize this example, we started with one 5G site. The AI agent generated a 7-site hexagonal deployment with 21 sector antennas and 105 UEs. The files were generated, the configuration was validated, and it opened in NetSim. Next, let us look at a code editing example. In this example, the AI coding agent assists the developer in implementing too late handover failure in NetSim, and the result is verified using the simulation output logs. NetSim already models handover. The UE moves, the network measures the neighbor, and the UE is handed across. But a handover is not instant. It is decided at one moment and executed a little later, and the UE keeps moving in between. Here the target cell drops below Q-out before the handover executes. In the real world, this handover fails. NetSim completes it anyway. Once a handover is triggered, it always succeeds. That behavior is missing from the model. So that is what we are going to add. One check at the moment the handover executes. Read the target cell as it is right now. Below Q-out, and the handover is aborted instead of completed. The UE releases the source cell and recovers through the path that radio link failure already uses. First, we create a 5G handover scenario in NetSim and save it as an example. We then open the saved example to review the configured topology. The scenario includes a moving UE, a source GNB, and a target GNB. The UE moves from the source cell toward the target cell, allowing NetSim to trigger a handover during the simulation. We run the scenario and open the results after the simulation completes. The results window shows the application and link metrics, and the handover log is then opened in Excel for review. At this stage, the log shows the normal handover behavior. Next, the experiment folder is opened from the workspace. This folder contains the saved NetSim files. A command prompt is launched from this location, and Claude code is started inside the NetSim experiment directory. The implementation request is then given to the agent. The task is to add the too-late handover failure behavior for the LTE-NR handover workflow. The prompt asks the agent to inspect the design and implementation notes, review the LTE-NR source code, apply the required logic, build the project, run the scenario, and check the output logs. Claude code reads the project files and starts planning the change. It identifies where the handover logic is handled and prepares the edits needed to test the target cell condition during handover execution. The modified source is then reviewed in Visual Studio. The added logic checks whether the target SINR has dropped below the queue-out threshold at the time of handover execution. This is the key condition for the too-late handover failure case. Even if the target cell was suitable when the handover was triggered, the UE may keep moving before the handover is executed. By that time, the target signal can fall below the required level. After reviewing the main source edit, we open the Code Compare option from NetSim Home to inspect the remaining code changes. This compare view helps us verify what was modified against the reference source. It shows the updated LTE-NR file side by side, making it easier to confirm that the added too-late handover failure logic is placed in the correct part of the handover workflow. After reviewing the code changes, the updated scenario created by Claude is loaded back into NetSim. We can now see the newly created example listed in NetSim Home, and we open it from there. Once the example is loaded, the topology appears in the NetSim GUI. It shows the moving UE, the source GNB, and the target GNB. In this updated run, the handover reaches the execution stage too late. By the time NetSim checks the target cell again, the target SNR has dropped below the queue-out threshold. Because the target cell is no longer suitable, NetSim records the event as a too-late handover failure, instead of completing the handover normally. We then run the simulation. After the simulation completes, the results window is opened and the handover log is reviewed. In the handover log, we can now see the too-late handover failure entry. This confirms that the updated logic detected the low target SNR condition during handover execution and recorded the failure in the simulation output. NetSim Plus AI agents can make simulation automation, debugging, and reporting faster. Use them to assist your workflow, but always review the changes and verify the simulation outputs.